Hello everyone, my name is Roman, and in front of me you can see those Adau speakers. Actually they are not original, they are modified right now, and you can see they are not connected to the power socket, so they only connected between each other. And now let me show you some magic. Okay, so you get an idea, and let me explain everything. So those are modified speakers. As you can see, I removed the original internals. So how do they work? So for the amplifier, I'm using the JAB5, and let me try to explain everything. As you can see here, I have squeezelite Wi-Fi access point. So actually for the connection I'm using Wi-Fi right now. You would ask me, why would you want to use Wi-Fi instead of Bluetooth? The answer is simple, because I have a big FLAC music collection. So JAB5 has already integrated Bluetooth aptx-hd with 500 kilobits bandwidth, but most of my FLAC files are 1.5 megabits, so Bluetooth will cut them and compress. That's why for my use, Wi-Fi is much better. So currently I'm using ESP32 S3 module. This is the other one, this is VRover, but currently I'm using the S3 VRoom. Yeah. So how does it all work? The ESP receives signal. Actually, the same thing is happening on my phone, but I connect it to my laptop so you can see what is happening. So what's important is here. If I click DSP, click on settings, here you can see that I have FIR equalization. It's EQ Harman. I have like Fletcher bass, Harman Moore bass, whatever. So I'm using linear phase equalization for that. And same thing is happening on my phone. So the ESP sharing Wi-Fi, I'm connecting to ESP with my phone. I'm running Lyron music server on my phone, and I'm streaming music to my amplifier. So that's how it goes. So here I'm gonna show you my project. Actually, you can make as many projects as you want. I hope you can see it properly. Okay. So let me explain to you. 4 and 5, those are I2S input. And here I have DC block. Here the signal duplicates. So left and right channel, as you can see. Here you can see FIR crossover for the tweeters, and here you can see FIR crossover for the bass speaker. So let me explain. You can see that here I'm using 246 instructions, and here 220 instructions. And you would ask me why so? Basically, each instruction takes some time, and because of that, I'm delaying my tweeter. So I measured step response of my tweeter and of my bass speaker, and it turned out that my bass speaker, my tweeter needs to be delayed to match the step response by like some amount of time. I can actually show you that. Actually, you can see the FIR equalization here with linear phase. A little trick, why do I have a second order all pass filter on the 75 Hz compensate? It's because my my port is tuned to 75 Hz, and with this little trick you could fix the phase of your ported speaker if you know which frequency your port is tuned to. So basically, okay, one moment. This is Liron music server, whatever. Okay, I'll open up a new reface so I could actually show you. Let's see, I'm using 246 taps, and let's say, I don't know, reject low. Okay, 100 Hz, whatever, let's put it 4000, and let me generate some. Okay, windowing, I'm using rectangular, sorry. So here you can see 123 samples, it's 2.7 milliseconds, and if I put 220, 2.4 milliseconds. So that's how I'm delaying my tweeter. What's the advantage of the linear phase crossover? That it doesn't mess up your speaker phase. Yeah, and here I'm having like 48 dB per octave crossover, and it would take me like a few seconds to change the frequency. So when there will be some study that crossover at 7000 Hz is superior to crossover on the 4000 Hz, it will take me for about like 50 seconds to generate it. I don't know. And here I could load the table values that I have, and that would be it. As you can see, I have already that much linear phase crossovers. So because this amplifier has integrated Adau DSP, I could have as many projects as I want, and I could apply any crossover that I wish. I could time match both of my speakers. I could match sensitivity. Here, I don't know, let's say gain. I could add gain and like decrease my tweeter sensitivity. I don't know, like 10 dB if it's necessary. I could actually decrease sensitivity of each speaker. So that's quite advantage because if you don't have digital processing, it will be really hard to time match your both speakers. So you will have only option is to move your tweeter like back, and with the digital crossover you could like just put any delay like here, like let's say samples milliseconds, I don't know, let's put it like 2. Oh, sorry. And that's it. Okay, it's 1 because here its maximum is 1. Let's say 3. Okay, and you're good to go. You have a delay. That's why I have this project. Okay, so now you understand. I could like show you here too if you're interested. So I'm using the ESP32 for the I2S input, and with linear phase crossover, and with the Liron music server, I'm using Squeeze DSP plugin with linear phase EQ. So it's actually quite an advantage over basic EQ, IIR EQ. Yeah, here you can see it. So yeah, that's how it is. Basically, I think have here it's old graph, but you get the point. Those are my measurements. Actually, I moved the crossover to the 4000 Hz, but you get an idea. That's how you can cut your speakers without any problem. So that's what I did. And yeah, I can change crossover frequency anytime I want. I could make as many projects as I want. I could make any EQs here with measurements. Here you can see Harman curve, whatever, match response to target. Actually, I need to adjust it a little bit. I'm just showing you the example. And yeah, so having all of that, EQs and crossovers, with ability to change them anytime you want, it's actually quite nice. Okay, so I think I showed you everything important. This is the Squeeze ESP web interface. Everything important here is this MCK frequency, MCK pin. I'm using it like that. Let me explain to you first that why would I use S3? I'll show you a little bit later instead of this one. So basically the problem I faced is that only 0 pin could be used for MCK, and then I'm powering on my amplifier. It is pulling 0 pin low, so board goes into download mode. Instead it should be high, so the ESP would boot properly. So I tried everything. I tried to put a resistor, capacitor, and nothing happened. Nothing helped. So board only goes to download mode, so it won't boot up. And basically, to make it work, I had to power on my speakers, turn them off, and quickly turn them on. And so ESP would boot properly, but I'll get this kick in the speakers, which I didn't like. So I tried to order S3 module of this board, JAB5 S3, and I had lots of problems with that, but whatever. Here you can see the firmware for the S3. You could just program it through the web interface, but currently it's not connected from a USB port. And yeah, this board, this V-Room, has Bluetooth, has Wi-Fi. S3 has only Wi-Fi connection, but I don't need the Bluetooth. So for me, Bluetooth is not important. Actually, I wanted to use only Wi-Fi. And this one works good with 16-bit firmware, and with 32 it works fine. The S3, I had lots of problems with the firmware, but in the end of the day I got it to work properly. Okay, so let me power off the speakers. I'm gonna show you the internals. One moment. Okay. So first the passive speaker. So basically it looks like that. Since I have like output for the 4 channels, I'm running 18 AVG 4-threaded cable to my passive speaker. Actually, I could paint it one day and make it look prettier, but currently it is how it is. So not too fancy. I think the cable length was it like 3 meters or something like, no, I think it was 5 meters, but currently it's a little bit shorter because I had to cut it and connect to the speakers. Actually, all of the speakers are connected with clips. So if I decide one day to change my tweeter or the bass speaker, I would just disconnect it, no need to solder anything, and put another speaker driver inside, and remeasure, and add another EQ, another crossover, whatever. Here you can see the active speaker, power on, power off button. Here is a DC input port. And here is output for the passive speaker. As you can see, it's isolated, so I don't have any short circuit. Okay, so you would ask me, how do you know if your battery is charged enough? So basically, have this DIY indicator. So basically, the battery inside, it is LiPo battery. I think it was 3,300 milliamps. So yeah. it just shouldn't be discharged below like 19 volts. So, and not charge more than 25.2 volts. So 23 is enough. Yeah, and for the charger, I'm using this one, 24 volts charger. Actually, I have plenty of DC step up and step down converters. So if I would need to charge it to 25 volts, I will totally do it without any problem. But for 24 volts, it's okay. Yeah. So basically, let me show you most interesting thing that is inside. Let me open it up so you can see for yourself what is happening inside. And one thing that I wanted to mention is that S3, JAB5 S3 has a Wi-Fi antenna that should be like 100 meters of range, but I don't need that much because I won't be too far from my speakers. Actually, I'm just taking them outside. So I put them somewhere on the ground or whatever and listen to the music. Yeah. And I will have like uncompressed audio with all my FLAC files. All I have to do is power on speakers, connect to the Wi-Fi access point, run Liron music server, and like just stream music. And that's it. Okay, we are almost there. Okay, I'm gonna open it up. Okay, so here you can see all the internals. This is output for the passive speakers. So basically anytime I could disconnect it and adjust and whatever. So everything is connected with these clips. Here you can see the power on, power off button. That's how it works. Actually, you can see DSP S3 LED. Here you can see charging port. Everything is isolated and works good. Yeah. So here you can see LiPo battery that I've put on the two-sided tape. It is on this side. On the bottom there is a JAB5 amplifier without cooler, because on the 24 volts it doesn't need cooling, it doesn't get too hot. There is hidden 5 capacitors with total capacitance. I think it was like 10,000 UF microfarads. Sorry for my English. Yeah, so they should be somewhere there. And here you can see the ESP. Actually, I'm using capacitors to avoid voltage dropouts. So basically, the LiPo battery is more superior to the Li-ion battery because it has like high current output. But anyway, I've used additional capacitors for that. Okay, so here you can see this ESP unit I'm using. Let me power it on. Okay, it works. You have this big Wi-Fi antenna for whatever reason. And I'm using it to stream music, this board. Yeah, so that's for the internals. I have battery, amplifier, I have like 5 capacitors, and I have this ESP S3 unit. Let me tell you once again. So with this module, everything worked fine. Only the problem was that I didn't want to power on, power off speakers to make it work. But every version, 16-bit and 32-bit, worked fine. Here, when I was streaming music on the 44 and 100 Hz, there was terrible noise from the speakers, and I didn't understand what is happening. So actually, the problem was that I had to stream music on 48 kilohertz and not 4400. So 48 kilohertz work fine, 24 bits. So basically, Neutron allows you to stream in certain sample rate. So I changed my project. I changed equalization, linear phase EQ to the 48 kilohertz, and it works totally fine without any problems. So yeah. So those are quite exceptional speakers because they have B-amping. They have truly a true digital crossover. I'm not using any passive components, right? So they have Wi-Fi audio input. So basically, I think it's quite nice that you have an option. If you don't want to use Bluetooth with it's like 500 kilobits, but if you're listening to the Spotify or YouTube with its 320 kilobits, it doesn't matter if you use Wi-Fi or not. It won't give you any quality. But if you're like me listening to the FLAC files, having Wi-Fi connection, it's quite nice. Total delay when I'm switching music is like 2 to 4 seconds, but it's nothing. So yeah, it has some buffer here. So if you're streaming music, it stores some data and then plays it. So for the music 2 to 4 seconds, it's nothing. And I have linear phase EQ, linear phase crossover. I'm not losing any data. Yeah, and I have the battery, capacitors, so no voltage dropouts. And right now, I think on the moderate volume, it would work like 5 hours. But I actually didn't test it how long they work from the one charge. But for 2 hours, they worked fine. Yeah, so that's how it is. So basically, I guess. I hope that I explained every aspect to you what is happening here. Maybe someone would want to build something similar, like portable, hi-fi, whatever speakers with linear phase EQ, like for the music, so you could take them anywhere you want. Yeah, with big, with long cable. Okay, so basically, if you have any questions about those speakers, so you could write your comments, ask them. Yeah, I will try to answer. I hope this video was interesting and I hope you could put your thumb up so the other people will see it, and I will help them to build something similar. Yeah, as you can see, everything here isolated. Yeah, maybe I should make this glue look prettier and paint it, but I think I will do it in the future when I'll have free time. So put your thumbs up. Roman was with you. Have a nice day or evening, and bye.